Let us see what is given in the question. See, ABC is a right angle triangle at C with 90 degrees. See, this is our diagram. Now it is given that M is the midpoint of the hypotenuse. I have already drawn the diagram, see, and we have drawn a line which is parallel to BC and that intersects AC at D. See, this is D. Now we are going to see the first part of the question. Now the first part of the question is we need to show that D is midpoint of AC. Now what are the things we know from this question? We know MD is parallel to BC, and we also know that M is midpoint of BC. From one of the theorems, we are clear that D should be midpoint of the corresponding side, which means D is midpoint of AC. Now this is our observation, which means AD is equal to DC. And we also know that from one of the theorems, now angle ADM should be equal to angle ACB. That we know. And what is angle ACB? Angle ACB is nothing but 90 degrees. Therefore, angle ADM is equal to 90 degrees, which means MD is perpendicular to AC. Now let us see the third part of the question. Now the third part of the question is we need to prove that CM is equal to MA is equal to half of AB. Now I am drawing CM here. Now let us consider the two triangles AD, triangle ADM and triangle CDM. Let us see if these triangles are congruent. Now see, AD is common in both these triangles, which means AD is equal to AD, right? And we also know that AD is equal to DC. That we know, right? AD is equal to DC, since D is the midpoint of AC. And we also know that MD is perpendicular to AC, which means angle MDC is equal to angle MDA, which is equal to 90 degrees. Therefore, from SAS property, from side angle side congruency, we know that these two triangles are equal. Therefore, triangle ADM is congruent to triangle CDM. If these two triangles are congruent, what can we say? Corresponding sides must be equal, right? Which means AM must be equal to CM. Therefore, AM is equal to CM, right? Now AM is equal to CM, and we also know that AM is equal to half of AB, since M is the midpoint of AB. Therefore, this is our answer.